over $100,000.
Yep.
One pair of these good cables, not this type. The good cables is a few $1,000s. So you do want to take good care of the equipment. Otherwise, your measurement is just garbage. Okay? A good connector can cost you a lot of money, a few $100s easily, right? Not this type, but a good one does. So one thing I want you to get used to a habit of, when you put on the connector, only turn the nuts only. Don't turn the device. So for example, can I borrow your can? Does the can has a...
No, it doesn't have ports on.
So let's say...
iPhone.
So that's okay, that's okay. I use this one. I use... Yeah.
I got one.
No, I don't need a connector. I just want to make a point. So let's say I want to connect my cable to this device. This is a male. A male connector has a pin at the center. The female has a hole, right? That's clear. So when you make them, you only want to turn the nuts. You don't want to turn the device. Okay, for a good cables, for a good set of cables. So does anyone have a marker?
Yeah, there's a marker right there. Underneath.
Oh. So we were saying the ground, RF ground is super important, right? So the connector, the male connector has a pin in the center, and the female connector has a receptor. Okay. Now the way they machine this is this will be inside, right? The teeth should be inside, this should be on the outside. Something like this. I'm not the best drawer, of course. Okay. So this is the male, this is the female, so they go in easily. Now what happens is, if you twist your devices, instead of the nuts, you are stripping this pin off constantly. So over time, this pin gets loose, and your measurements becomes garbage. Right? So have that habit of only turning the nut. One side, the nut is always free to rotate. Okay, so only do that. So who wants to do this, please? Come on. Connect one side. These are not expensive. These are the few dollars one. And then the other cable is, connect the other cable. The on-off switch is right here on this side. Okay, turn it on. Yeah, the on-off switch. So when you turn on, okay, this is what you're looking at. Usually, it's one trace. So on the top, it says channel 1 S11. Right? We are looking at S11, we're measuring the reflections. The frequency is start at very low to 3 gigahertz. Okay, the default setting is 3 gigahertz. For those who want to measure up to this one, can go to 6 gig. So if you want to go to 6 gig, you need to, I believe, let me see, local. Where does that go? System. Okay. Under system, there's a frequency range, 3 gig. If you press on it, it goes to 6 gig. Okay, you just play with it. So you can measure up to 6 gigahertz. Now you can have multiple plot. You can look at both S11 and S22 together. So here I have channel 1. I press channel 2. Channel 2 is S21, but you can change it. You can change it any way you like. So if I want to look at both, I believe the display button here, the first one is dual channel. You say on, then you look at both S11 and S22, right? One on top, one on the other. But then that cut down the screen in half, and I don't like it, so I'm going to say, how do I change it? display, split display, no. You say on right now, I say no, off. So now everything is the same screen, right? The red line is where the 0 is, so we can change that too. Go to scale. Scale here, press the scale button. Go down here, there's a reference positions. So I'm gonna move it up, right? That's channel 2, so you see the S21, the transmissions. And then I'm gonna press channel 1, look at the reflection, again do the same thing, and under scale reference position, I think it's still under. Okay, so the yellow one is the reflections and the blue one is transmission. Now, having the setup like this, does that make sense?
Yes.
The S11 is almost on top, the S21 is almost the bottom. Does that make sense?
No.
Yes or no?
Because it's total reflection.
Total reflection, right?
Yeah.
Total reflections, that means it's almost 0 dB. So the yellow one should be on top. There's almost no transmissions because they're not connected. I mean, although you can kind of put them closer, you can see you can see the change, right? Okay. So so almost no transmission, so it's at the bottom, right? That makes sense. What else can you change? If you want more resolutions, you can change the number of points by, I believe it's under, let me try manual. Under manual in the stimulus manual here. So you can change the power, it's internal power. You can change the trigger manual, you should know. Number of points, okay, default is 201 points, so that means from the lowest frequency to higher frequency is 201 points. Usually that's not enough, so you can do, a lot of people do 401 or 801 points. The more points you have, the longer it takes for each sweep, of course. And then just say enter. So now you have more points, right? Okay, now this entry. So you set up the frequency you want to measure. You don't want to measure from 0 to 6 gig all the time if you only look at a very narrow band filter, for example, right? So you want to zoom in, and you can change the frequency setting here. So let me say I want to do 1 to 2 gig. So I say start. You have the frequency start here, right? Start, and then you say 1. And then the unit is here, giga, mega, kilo, and hertz, so 1 giga. So I have start from 1 gigahertz. I'm gonna stop at whatever you want, say 2 gigahertz.
5 to 6.
So I'm gonna hit stop, 2 gigahertz. So you can see the manual at the bottom, say start at 1 gigahertz, stop at 2 gigahertz, right? Okay. All right, so let's say this is what I want, and now you need to do a calibration. What does calibration do? In your homework, you calculate the C impedance, you calculate gamma, right? By measuring open short impedance. This is exactly what the network analyzer do for you. So we have the cal standard. One is open, one is short, one is low. Low is just 50 ohms. Okay. So I'm gonna hit calibrations. The cal. Okay, calibration is off right now, so I'm gonna say calibration, calibrate manual. I want to do a full 2 ports. Okay. Yeah. If you are only looking at antenna, the matching, you can do S11 1 port only. But for the most cases, I'm going to do as full port. So the first manual is reflections, and you take the first cable from the first channel. Okay. Let's say reflections, S11, the first side, open, so you connect the open find out which one is open. This side is open, this one is short. I'm going to keep this in review and you don't lose it. So, and then you say open. So it's calculated for you. It's take a long time. Maybe we should do 400 points. And then the second one is short. So basically, you just go through the menu. It'll beep you after it's done. And then you put the third one is low. So you just go through this cycle for both of them. Who wants to do the second port? I'm tired. Low. Okay, who wants to do this? Come on. Come on.
Can't read it, sadly.
Open, short, low.
So,
So-
does the calibration, does it remove the effect? Is it because we are trying to remove the effect of the coax cable?
So yeah, so what it does is it calculate, take all the impedance of your coaxial cable, all the losses, and your phase. And so put the zero phase right at the connector.
Is this S22 or S11?
S22. Open, you're doing the open. Right.
How
Wait
often-
until you beep. Yeah, okay.
How often do you need to calibrate the?
What did you press?
Every day because I pressed short before.
Oh, okay.
How often do you need to calibrate?
I don't, people at work, they usually calibrate every day. But it doesn't change that much from what we do here. If you save a calibration, you can save a calibration with your name, then you can use it.
Okay.
Yeah.
Oh, you can save it?
Yeah, you can save it. So you don't have to redo this every time. I don't know how many registry you have, but so you just go through that cycle, open, short, low.
That means if I change the coaxial cable, then I need to create.
If you change a cable, if you put an extension of the cable, then you should recalibrate it. Except when you're doing antenna. If you're only measuring the radiation pattern, that calibration doesn't matter. It's only a relative measurement, yeah.
So if I'm going from N-type to SMA, I should recalibrate? What's the SMA one?
Well, I don't have an SMA calibration kit here. I don't think they do. So either you borrow one from work, or just stick with N if you could. Or just ignore it, because that should be small. What are you doing again? What's the project?
Directional coupler.
Huh?
Couple of
Oh, yeah, that's only like 0.1, 0.2 report review. Done?
Yeah.
So after you're done, you press reflection, done, right? I did, it's calibrating, it's slow. It's a very, very old. Oh, I don't have, oh, shoot. Do you have a through, a barrel? Female? Can you bring one in? Okay. I only have a male to. So after that, we don't have a barrel. So there's a connector. You say through. You connect this cable with this cable with a through. We need to get one from me. Okay. And just go through all four of them. After that, I'm just going through it. After that, it will ask you whether you want to do the isolations. And usually you can skip it unless you're looking for like very low isolations. So you say, okay, this is done, isolations, you can omit it. And then you say you're done, and the thing start to do all this calibration for you. And after that, you can store your calibrations. It's computing. And then now you can save in register 1, 2, 3, 4, and so on. You can name it. You can name the registry too, right? So that's what you practice it. Make sure you can do it. Now, how do you know whether the calibration is good? After that, you can connect this to an open. And if it's connect to the open, let's say the port 1 connect to open, what should the S11 be? Huh? How many dB? 0 dB, right? So if the calibration is good, when you connect open or short here, you should see the yellow line all the way on the top, flat, no ripples. And then if you connect these two together with a barrel, then the blue line should be all the way on the top. The yellow one should be pretty low, like 40, 50 dB, right? If you have question, always ask. Don't assume. Okay, if you're not sure, take a picture of this, post it on Canvas. I'll tell you if I see it. Okay? Questions? Okay.
What type of connectors are those?
N-type. Yeah, it's called N connector. N connector is popular for a little bit low frequency and also in the oldest communication system, and because they can handle more power, but it's bulky, it's bigger. So the new standard is the smaller SMA, or even smaller, called SSMA, small SMA. SSMA. But there are many, many types, many types. Okay, no questions?
I have a question.
Yeah.
So to actually observe like the peaks and stuff, is there like a cursor that you control?
Yes, there's a marker. There's a field marker. There's a marker function too. You can measure the, marker 1 here, marker 2 here, set 1 as a reference. What's marker 2? What's the delta F? And also what's the delta amplitude?
Question, upfield was 5.8 gigahertz. Is that too high? Or is,
What's the bandwidth?
150.
Ooh, you barely can see it.
It goes a bit over the like current simulations, so it's not like exactly 150. It's like
So would it be like within the tolerable values?
Yeah, you can measure it first.
Okay.
But after you're done, you give it to me, I'll measure to higher frequency for you. Because I do want to check the third harmonics to compare that with your simulations.
third harmonic is still pretty high. The second one I thought they were